In this video, we're going to be doing some review Cambridge practice questions. This is for section 13.1 in A-level computer science, and that is user-defined data types. So let's jump right in. Number one, data types can be defined in a programming language. The data type, student record, is defined by the code. So we have this code right here, and I noticed some things right away. I noticed an integer, I noticed two strings, I noticed date, and an array of a string. So I know right away I have more than one data type. Anytime we have more than one data type, I know I'm dealing with a composite data type, which is known as a record. So I have a record here, or I have composite data type. Because there's no list and there's not only one data type, I know that I'm not working with enumerated data or non-composite, but because there is more than one, I am working with composite, or what we call a record. So it says a variable college student is declared with the code, and they're declaring college student as student record, which gives me access to student ID, first name, surname, their date of birth, and student course, which has an index or lower bounds of 1 and a upper bound of 10. Write a pseudocode statement to assign 6,539 to student ID of college student. So this is worth 1 point. No partial marks here. Let's pause and give this a try. Okay, so we declare college student. So I'm going to go ahead and write, that's my variable, college student. And this one's very easy. Now, college student has access to a multitude of things. And college student, because it's been declared as student record, it has access to student ID, student first name, student surname, student date of birth, student course. Well, it says to student ID. How do I access these things? I simply put a dot, and that's why I have a dot there. And I'm going to do student ID. And I'm going to write it just like Cambridge has it, so there's no room for confusion. Now remember, in pseudocode, we don't use an equal sign. Simply draw an arrow, and then we write 6,539, and we are done. We just got our full point. Let's jump to the next question. Number 2, the type definition for student record is changed. Now, what I did was I copied and pasted this over here in case we need it. And if we need it, we're able to access it. Students can take 6 courses from computer science, engineering, science, maths, physics, chemistry, music, drama, and English language. Rewrite one line from the type definition of student record to implement the change. So we're talking about 6 courses, and it's important you may want to underline some pertinent information. There are 9 courses listed. Students can take 6 courses, and I know that's of course dealing with student course. So they want us to rewrite it. Let's pause here, and you take a moment to answer this. Okay, so what you should have here, they have declare, and you're going to do student course, and we'll break this down into how you get the points. So I'm trying to write my best here. Student course. And that, of course, is going to be an array. We still haven't gotten our 1 mark yet. We'll talk about how you can get 1 mark. And then we open up our brackets, because remember in pseudocode it's brackets. Now we have to set our lower bound, which is going to be 1, and then we need a new number. So at the beginning we had a lower bound of 1 and an upper bound of 10. That's what we had, and it says students can take 6 courses, and there are 9 courses to choose from. If you skip over where it says students can take 6 courses and you're like, oh, computer science 1, engineering 2, so on, all the way to English language, what's going to happen is you're going to write the code wrong and miss out. Students can take 6 courses, and because we're listing student course, this is going to be a lower bound of 1 and upper bound of 6. That is 1 mark point right there, or 1, yeah, that's 1 point right there, but this is worth 2 points. Because it's an array, we cannot create a list here. Because we're not creating enumerated data, these must be strings. So what I'm going to do is I'm going to abbreviate everything just for sake of time. The first one is comp sci. That's 1 course they can take. The second one they can take is engineering. The third one they can take is science. Now, when you're taking your Cambridge exam, take the time to write these out. Do not abbreviate it. I'm just abbreviating for the sake of time. The fourth one they can take is maths. That's one option. Physics. They can also take, let's see here, we got chem, music. They have drama. And the last one they have is English language. So we'll just put ENGL to distinguish, close my parentheses, and I'm done. Let's move on to number 3. Data types can be defined in a programming language. All I did was copy and paste this in case we need it. The values for the field student ID must be between 1 and 8,000 inclusive. So we had it as an integer where they could type any number. Now it wants us to redefine student ID, so it's 1 to 8,000 inclusive. Let's go ahead and you give that a try now, and we'll go over the answer. Okay, so all we're going to do is we're going to redeclare student ID, but we're going to give it some limitations. So we're going to do student ID, and that's going to be 1 to 8,000. So what we're doing here is we're creating a list inside of our data type. We're not declaring it as an integer. We're saying they can do 1 to 8,000. The reason we're doing it as a, or this actually should be parentheses. Let me fix this because this is not an array. So we want to do this as a parentheses. My handwriting's so sloppy, I thought I wrote an open bracket, but I didn't. So 1 to 8,000. The reason we can have a list is because we're dealing with 1 to 8,000. So if I'm dealing with student ID number 57, I know exactly who that is, which is also the 57th spot in my list. Let's move on and take a look at the next question, number 4. Programmer is asked to write a program to process the assessment data for each student. Students sit one exam in every course they take. A composite data type, student assessment, so it gives us the type, needs to be defined with the following 3 fields. So we have a student assessment code, which is a unique code of 3 letters and 2 digits. That is important because that gives us it right away. We have the marks for 6 exams, the average mark of 6 exams. Write pseudocode to define the data type student assessment. So let's pause here, give it a try, and then we'll go over the answer. Okay, so this one's worth 4 marks, and so you have a lot of things you can do. But let's say you don't know how to do this, and all you know how to do is do the type. No problem. That will give you 1 point. So we're going to write type, and they already gave us what it's called, student assessment. So all we need to do is write that. Well, there's actually one small other thing we have to do, which is almost a give me. Anytime you have type, you also need in type. Straight off our notes that we did in class. So right there, we get a point. Now, it says a student assessment code. All right, fine. Let's do a code. Now, there's lots of different names you could write for this. You could do student assessment code. You could do something else. I'm just going to do code. A unique code of 3 letters and 2 digits. So that tells me right away that this must be a string. It can't be an integer because we have 3 letters. Well, what can handle alphanumeric? A string. A string is not just for letters, it's any alphanumerical character, which is both the alphabet and numbers. All right, the next one, the marks for the 6 exams. Okay, so maybe back in pre-ACE, before we learned how to do one-dimensional arrays, we may have to do test 1, test 2, test 3, test 4, test 5, test 6, or exam 1, whatever. So what we're going to do is we're going to do marks, because that's the score for the 6 exams, and I'm going to declare that as an array. And because they took 6 exams, my lower bound is going to be 1. My upper bounds is going to be 6. And because I'm recording their score, that's going to be an integer. Nothing very difficult there at all. And then my fourth and final point will be declare, and that's going to be the average mark of the 6 exams. So I'm just going to write declare. I'm going to do AVG mark. It says, yeah, the average mark. So I'm just going to do average mark because there's only one. And that, of course, is going to be real because we're going to be dealing with a decimal. And just like that, I got all 4 of my points. So that's it for 13.1. I do have a bonus question for 13.2. Data about all students and their assessments are stored in a file that uses random organization. And because they tell us it's random organization, I know that hashing is going to be involved as well as some key terms. The student ID is the key field. Oh, look, they gave us one right here. Key field, that's a key term to know. The program allows the user to enter data for a new student. Explain how the program adds the new data to the file. Let's pause here and give you a chance to do this. Anytime random organization is used, it's direct access. For example, if there's a list of 100,000 students in a file, you're not going to start at the beginning and search from the beginning of the file all the way to the end when someone enters their ID. It's going to jump directly to them. We call that direct access, and that is through random organization. So the program allows user to enter data for a new student, and right here, the student ID is used as the key field. So the student ID, so explain how the program adds new data to the file. Student ID is hashed. Now that's not, you can't just say it's hashed. You have to say why it's hashed. And to find the home location. And the home location is where data in the file is stored. That is why it's hashed. So if you just say it's hashed, to find the home location, you're thinking that's 2 marks. It's really only 1. You have to explain why it's hashed. And it says explain how the program adds the new data to the file. When the student ID is hashed, one of a couple things can happen. The first one is if the location is empty, then the new data, and new starts with an N, not with a M, then the new data is added. Now, another option, and we're going to go more than 3 points here, because let's just go over all of it. They only want 3, but we'll do all of them. The other possibility is that the location is not empty. So if the location is not empty, all we're going to do is continue searching for a space not occupied, because we don't want to overwrite anybody's information, or that's one option, and this would really, you could write either one. So if the location is not empty, we're going to continue searching through the file for a space that's not occupied, or we send data to an overflow area. And in class, what we did was we hashed everybody's name, and if there was a collision that occurred, we moved to the next open spot. If we had too many students to handle, we would send a collision and handle it to an overflow area. We'll do that in another video later on, redoing the hashing video we had earlier. The other option is if, I'm trying not to, there we go. If there is no free space, and this means all the locations are taken up. If there is no free space, file is full. We could all just so simply say if the file is full, the data cannot be added. So the data can't be added. Trying really hard to write small enough to fit it. And that is an N, not an M. I wrote it in but because I'm trying to fit it, kind of messed up. All right, so that is all for 13.1. If you have any questions, please post a comment below. I hope you found this helpful. We'll see you guys in the next review video that we do later this year.